Okay, so this is going to be the Intermediate Design Studio PCB lab, and we're going to be working in EasyEDA to create a very simple Arduino Nano-based NeoPixel board. And so the goal of this is to show you how the software works and get you designing a circuit. And so to start off, we've got EasyEDA logged in, and I've got it pulled up, and we are going to come over here and start with a new project. And for the owner, you should have joined up with the Fall 2019 Design Studio group. And so we're going to make that the owner. And this will not only give you access to it, but me as well, since we're going to be creating these as a class. For title, I'm going to call this PCB Lab, and then first initial, last name. And for description, we'll call this a simple Arduino Nano-based NeoPixel circuit. Okay, it's pretty descriptive, and we'll click Save. Okay, and it's going to pull open this blank schematic sheet, and we're going to go ahead and just change our title to PCB Lab. For company, you can put your name if you would like, and I'm just going to go ahead and save this now. Now the goal here is to just find all of our components, get them on the board or on the sheet, and just do some basic connections between them. And that's going to help us just understand what it is that we're working with. So I'm going to hit Shift F, and you will probably end up with this this library search bar. And if you come down to Fall 2019 Design and click All, what that should do is load all of the components that we'll be using for this lab. So I've kind of gone through LCSC, which is our component provider, and just narrowed down their billions of components into just the 5 simple ones that we're going to be using for this lab. And so we're going to start off with our Arduino Nano, okay, and we need one of those. And so if we click on that, we drag it over here, we can drop one onto the page. So, and for simplicity for this lab, we're using the Nano, but for other classes, we can use things like @tiny85s. But just to, like I said, keep things simple, we're using the Nano. We're also going to need a capacitor. The capacitor is going to help smooth kind of the power that's moving through the circuit. We don't want it to hit the NeoPixels too hard, and so this kind of prevents the NeoPixels from getting surged with electricity and blowing out. Okay. Next thing, we're going to grab push buttons, and we're actually going to grab 3 push buttons. We'll have 3 different animations that we're going to show, and I'm going to bring these down here. And so each push button is going to control a different animation that you will program. So for that, we're going to next go into our library, and we're going to find resistors to go with those push buttons, so buttons like 10K resistors. So we're going to come in and just drop a few 10K resistors here, one for each of the push buttons. Okay? And then for the crux of the design, we need our NeoPixel. Now, the actual part number for a NeoPixel is this WS2812, and this is a very special variant of the NeoPixel. It's called the D-F5, and what that is it's not that surface mount version that we're used to seeing in the NeoPixel strips, but rather it looks like a little light bulb, but it's a NeoPixel inside. And so we're going to grab that, and we're going to need 9 of these. So I'm going to come down and create 9 of them. Now on these schematics, it doesn't really matter how you organize them. So as long as it's logical, when we get to designing the board, that's when the actual placement of these is going to be, super important. So I've done kind of like 5 here and 4 here to make 9. On the board, we'll actually do it as a 3x3 matrix. Okay, so now that we've got all of our components down, now we need to sort out how we're actually going to go about connecting all of them. So I'm going to take this moment to save up real quick. So, and one of the very first things that I'm going to want to do is just make all of my power and ground connections. And so if we come up to our wiring tools, you'll see that there is a VCC, that's our power, and you'll see this little ground flag, that's our ground. And so we'll start off with ground. And what I'm going to do is I'm going to go to each component and make sure that it has connections to power and ground. So here's my ground connection for the Arduino, I'm going to do a ground connection for this capacitor. Okay, we're going to do a ground connection, and I'm hitting R to rotate that. Ground connection for our resistors. Okay, so we just drop each of these here. Notice how they're not actually connected just yet. We'll come back and connect them in just a moment. And ground for each of our NeoPixels. Okay, what's nice about this is, one, it ensures that we don't have just tons of wires running all over the place. We could connect all these with wires, but these little flags just let us say that these are all going to ground. Okay, so at this point I need to actually connect these, and so I'm going to use my wiring tool, and I'm going to make sure that I come over and I'm looking for that black dot that makes sure that I have a connection. I'm going to click here and come over and actually make a connection on that ground. And I want to do that for each of them. You really want to make sure that there's a green line there that's connecting the two. Sometimes it can look like there's a line there, but it hasn't connected all the way across. And if they don't connect in real, in the diagram, they will not connect in real life, and that will be bad. Your circuit will not work if that is the case. Okay, so we're coming through. We're connecting all of these ground connectors. Okay, and we should be good. That's all of our ground connections. Okay, we're going to come back and we're going to do the same thing for our power connections. So I'm going to come in here, and that's going to need power. Okay, so I guess I'll move this guy right about there. It's not the most balanced thing in the world, but that's okay. Okay, and I'm going to add power there, power there, power there. Okay, I'm going to come out here and add power here. Oops, I don't like that placement there. Let's try that again. There we go. And I'm trying just to, find a good placement to where, I can make things look nice and clean and somewhat sensible. So I'll come over here to my wiring tool again. And again, we'll just, like we did before, we'll just wire these up to make sure that every one of them is connected the way that it needs to be. There we go. So you can see that I usually try to place these so that I can just connect them up to their appropriate components just with a single wire line. I keep things simple, but it's not always possible to do, so if you have to place them somewhere else, that's okay. Just try to be careful about how you're placing them. Okay, so that's all our power and ground connections. Okay, so now what we can do is we can begin thinking about kind of our greater circuit. So we're going to start over here with our push buttons. Okay, and so we know that on a push button that we're going to want to connect our resistor to the actual push button. So we're making what's called a voltage divider, and then these have to get dialed into the actual circuit somehow. And so what we can do is we can come off of this pin 2, and we can come and bring those up into some digital pins. So I'm going to connect mine. I'm going to bring this one around and up. And I'm going to hook mine up to, we'll say, D10. And you can choose whichever one suits you best. So I'm going to bring this one up and bring it over into D11. Okay, I'm going to bring this one up. And bring it into D15. Okay, so each of these is hooked up to its own digital pin, and that's going to allow us to write some code that will be able to read them. Okay, now we have to figure out how to wire all of these guys up. Now, I am going to kind of change things up a little bit here. So I'm going to, first of all, kind of adjust these labels to make them look a little bit nicer. And I'm going to look at the wiring, the way that these are going to wire together, and try to make it work as cleanly and sensibly as possible. So I'm a stickler for making things look nice and orderly, so we're going to try to kind of clean these up. Now, one of the things that's going to be kind of an interesting challenge about this is that when we're writing code, these LEDs are going to have individual addresses, and when we make the circuit, it starts at LED 1. But really, it would be nice if that was LED 0. So I'm going to come through and just double-click on that label. And I'm just going to come through and actually just relabel these so that our code will match up a little bit easier with our LEDs when we do it. And that'll make programming it a little bit easier so we can actually see what, if we say LED 4 turn on, well, we'll be able to actually see that LED 4 is on, and there won't be confusion there. So we'll come around and we'll just relabel these really easily. Okay, and we're good. So we have 9 LEDs, that's 0 through 8. Now you'll notice that we've got kind of this D in and D out. And so we're going to kind of be looping some connectors around, and that should be okay. I'm going to come across on D9, and I'm going to bring it around here. Okay. And just come make that connection to DN. So the data comes out of the Arduino and into this LED. And then it's going to come down and connect, not to there. I'm going to come out of D out. Okay, so click down, and it needs to come over into this D in. Okay. And we got to be really conscientious. This is where things are getting a little bit kind of squirrely here. So I'm actually going to move these guys out a little bit just to give myself a little bit more breathing room so that those wires aren't jumping on top of each other. So again, we want to make sure that our connections are all nice and solid, and that things make sense when we look at them. So we need to be able to look at this and actually say, yeah, we understand how all these connections are being made. So just giving myself a little bit of extra wiggle room here to make those connections. Okay, so let's try that again. Okay, so we've got our D out. Okay, and that can come out here and go to D in. Go to D out and into D in. Out and over here to D in. And one last time we'll go D out, and this time we're gonna kind of do a big loop here over to D in, D out to D in, D out to D in, D out to D in. And obviously this is our last one, so it doesn't need to go out anymore. Okay, so I'm going to go ahead and save that. And just do a quick double check to make sure that it seems like I've got all of my connections made up, and this does seem reasonable. Okay, so I've gone ahead and saved. And now we're ready to transfer this over into a circuit board. So we're going to come up here and click on Convert to PCB. Okay. And it says there are some unfinished nets. Ooh, let's check those nets. What does it think that I have not finished? Okay. So yeah, so it looks like it's saying that, well, you didn't connect this up or this up or this up or this one up. And that seems okay. And lots of connectors on here, like we don't want those to be connected. So that seems to be okay that those are unconnected. So we'll convert to PCB and we can say, no, keep going. We've hooked everything up that we want. Okay, so now you can see that it's thrown all those physical components onto this space, and our job is going to be to, again, kind of rearrange them the way that we want them to physically appear in the printed circuit board, and then we'll run those final traces, those routes of copper traces. So before we get kind of started on that, we're going to change a couple of things. For units, I like to work in millimeters. It just seems to be a lot more kind of friendly and real world. For grid size, I'm going to change that to be 5. And for snap size, starting off, we're going to do kind of a rough layout of things, so we'll just make kind of a 1 millimeter snap size. So we're going to look at kind of what our overall layout of this is going to look like. We'll think about what's going to make sense. And this is this pink line here is the profile of our circuit board. Now we can change this, and we probably will. And so for now, I'm actually going to click on this guy and get rid of him, because I don't know what the final shape of the circuit board is going to look like. So I'm going to start off just with this rough idea of just beginning to lay some of these components out. You may notice that kind of like when I'm placing this capacitor, boy, I wish I could rotate it, so I can just select it and hit R. You see how these wires are crossing here? So I'm going to kind of keep hitting R, and you'll notice that they kind of untangle themselves, making that a little bit easier. Okay, I'm going to bring, I think what I'm going to do is I'm going to have kind of like the buttons here and the microcontroller here, and maybe my 3x3 of LEDs hanging out over here. So I'm going to have switch 1, and switch 2, and switch 3, maybe something like this, and then I know resistor 1. Again, you can see how that's crisscrossing there, so I can just hit R to reverse that around. Okay. And just make everything kind of standardized. Okay, now for my LEDs. So I'm going to have LED 0 there. LED 1. I just want to kind of space these out, somewhat evenly. So that it looks just nice and well organized. Okay. Good. Okay. So they're well organized. Now if I'm looking here, it actually looks like I could possibly get a slightly smaller footprint if I went ahead and moved my buttons over on this side. So I'm going to do that. So I'm just going to place these kind of centered under each of these LEDs and move my resistors along with it. So again, you get to decide how you want to organize them. We'll just try to choose something that seems logical and relatively compact. One of the most important aspects of PCB design is minimizing the footprint. So you can make it smaller, then you should definitely make it smaller. Okay, so here we go. Now we've got this kind of in play. We're going to go ahead and do our board outline. So I'm going to kind of come over here on this Layers and Objects panel, and I'm going to click on Board Outline. And that's going to let us kind of redefine our board outline. For this, I'm going to change our snap size to 5. That's going to kind of make it, have a nice coarse outline. And I'm going to come over here. I'm just going to click. Let's do click here, and I'm going to click one time here. And these are all left clicks, okay? And then I'm going to right click, and that should leave me with a completed board outline. And I can hit escape to make that go away. So now that's kind of the outline of what my overall PCB is going to be. Okay, so we can go back to editing our top layer here. Okay, now we see how these blue lines, and these are what are called rat's nest lines. They show us kind of how the pins should connect together, but these are not yet physical copper traces. We need to kind of work that into ourselves. So we're going to work around this board adding these copper traces, but we want to avoid some in particular. Anything that's a VCC or ground connection, we're going to save for the very end, and I'll show you why. We're going to do what's called a ground plane that is going to make doing those connections much easier. So anytime you see a VCC or a GND, don't worry about that one just yet. I'm going to show you a really easy way to do those just all at the very end. But we do need to worry about any of these like data connections, for example, or any other kind of non-VCC or ground connections. So what we can do is we can choose one. So I'm going to look at this D9, okay, and I'm going to click my wire, and I know that that D9 needs to come over here and connect to the LED. And so if I grab that, I can just begin clicking and make that connection. Let's see, did I do that correctly? Okay, yeah, it looks like that one is good, and that makes that rat's nest line disappear. Okay, so I'm going to come over here, and I'm going to change my my snap size back to 1 millimeter, and just adjust a couple of my labels here to make them a little bit more attractive. Okay. So again, this is going to help in the production and fabrication of the board. So that does matter. We want to make sure that things make sense and they look good, even though it's just a circuit board. Okay. So, and let's do like that. Good. Okie dokie. All right, so let's continue making our wired connections. Okay, so I know that my next wired connection is going to be coming from here over to there. Okay, well, that's very convenient. Okay, there, over there. Good. So that nice organized layout has made this fairly simple for us. So that's very good. Okay, next connection. And you notice that we are avoiding making any 90-degree angles. That's important. That's just a good aspect of PCB design. So if we can avoid, we should absolutely avoid those 90-degree angles. So I'm going to keep kind of modifying this until it gives me a nice 90-degree angle. So that's routing angle is 45. So let me do that. Okay, so I'm going to kind of click out of that to get rid of that 90-degree angle. Okay, and again, we should just be able to click through on these, and and once that connection is made, I'm just hitting escape to jump out of the wiring area. Okay. Okay, so that should be all of our LED connections, at least all the ones that are not ground or powers. Okay, I'm going to come with her and work on our switches a little bit. So I'm going to just come over here and hook up our resistors to our push buttons. Okay, so far so good. And then let's hook those push buttons up to our PCB. So I'm going to bring this over here, and again, just want to kind of follow along here. So we can hook that one up there. Okay, and I see that I've got a 90-degree there. I don't really like that. So I'm actually going to delete this one and redraw that to avoid a 90-degree angle. There we go. Okay. So again, we just want to avoid those if we can. Okay, so let's take a quick look. Looks like lots of things are still hooking up to that VCC and ground. And what we can do is we can just do a quick save. We're going to call this, again, our PCB lab. This is the actual circuit board portion of it. We're going to come over here on nets, and we're going to open this up and see that for some reason it seems pretty grumpy about what we've done here. Why is it grumpy? Interesting. So let's refresh that. Ah, there we go. Okay. So we just had to click refresh, and you can see that the only nets that aren't set up now are the ground and the power. Good. Okay, so that's where we want to be. So now what we can do is we're going to do what's called a ground plane. And the ground plane is going to create just a big giant piece of copper that's going to come through and actually connect all of the points that need to go to ground. Okay, so the way that we do that is we're going to set our snap size to 5 millimeters. And we're going to come over and we're going to click on this copper area. And we're going to start in the corner. And we're just going to click on one corner, 2, 3, 4, and then come over here and right click. And what you can see is it has turned, everything that's red is now a big piece of copper. So if we zoom in on one of these areas that was supposed to be ground, you can see how there's these little wedges, and that's connecting that pin to the ground pin now. If we go over here, we can see that that's true for this pin over here and for this pin over here. And that's good. That means that we instantaneously made all of those great ground connections. Okay, but we also need to do our power connections. And so what we can do is we can go to the bottom layer of the board. These are 2-layer boards, and we can repeat the same process. And so I'm going to go ahead and turn the visibility of my top layer board off. I just want to see my bottom layer. And I'm going to do the same thing. I'll come over here to copper. And 1, 2, 3, 4, and right click. Okay. And at this point, you're like, wait a second. It didn't hook up all those VCCs. And that's because when you use this copper fill area, by default, it makes it a ground connection. We want to make this our VCC connection. So I'm going to turn off the board outline, and that's going to let me click this little dashed line. And if I click on this here, over on this side, you can see that it says net GND. Okay, well, I want to make that VCC. I want to make that my power line. So if I hit VCC and hit enter, suddenly you can see that it's gone through and all those VCC connections, it is now filled in and connected to that bottom board. So I can come over here to board outline, I can turn my top layer back on, and at this point if I hit refresh on my nets, what I should find is I should have 45 out of 45, or however many you have, connections that have been completed. And that's great. I'm also going to click this refresh on DRC Errors. This is our design rules check. It's going to look to see if we've made any kind of huge mistakes. It doesn't look like it has. Okay, so I'm going to go ahead and save that. And our next part is adding a little bit of text. So I'm going to come over here to the text tool, and I'm going to just click out here. And for this particular text, I want to put it on the top silk layer. So the silk layer is where they're actually going to put ink on the board. And so if I double click that, I'm going to put PCB lab Zane Cochran on it. Okay, and we can place that wherever we want. I'm actually going to change the font, so I've got a Roboto Slab, which is the Hackberry Lab font, loaded in here. So I'm going to click that since I like to make things consistent. And I'm going to change my snap size to 1 millimeter, which is going to give me a little bit more kind of, positioning freedom to put it where I want to. So I'm just going to come in and bring it in here, and that is our board. Okay, at this point I'm going to save. And for the lab, you need to do a few things. So first of all, you need to export your design schematic and turn it in. You need to export this schematic and turn it in. And then you also need to load a photo view or a 3D view. You can choose which one. But when you do that, what it will do is it's going to show you a picture of what it's going to look like. I suggest when you do this that you change your background to white. It'll make printing it out a lot easier. And you can even choose a different board color if you want. The boards are going to come in as green, but if you want to make it look like it's fancy or something different, then you're welcome to do that. Okay, so that's the photo view. If you want, you can do the 3D view as well, and that's going to just let you, zoom around your board and see it from a variety of different angles. And so here we go. So if you want to be fancy, you can export a 3D view of your board as well. Once we get ready to produce these, and we'll be shipping these out in batches, we're going to go up to our generate fabrication file, and we've already done the design rules check, so we don't need to worry about that. But what you can see is this is what it's going to be shipped off like over to JLC PCB, where we get our boards manufactured. and you can choose your quantity. We'll be getting quantities of 5, and the total price for 5 of these boards is $2, so that's really good. So at some point you want to go into business and you want to make 1,000 of them for some reason, you can do that, and you can get 1,000 for $268. So it's a pretty good price. But again, we'll be doing this as a class, so you don't need to worry about this. But if you're just interested in kind of figuring out, how long does it take to make or how much does it cost, you can click on that fabricate, button right here, and it's going to tell you all about that. So that's it for making the PCB board. So when you're done with this and we get them manufactured, your job then is going to be to actually program these with 3 different animations. So it could be rainbow, could be blinky, whatever you want to do. And each of those is going to be triggered by pushing one of these buttons. And that's it.